The science exploration textbook uses two important symbols, magnifying glass and compass. The magnifying glass represents careful observation, and the compass represents direction in scientific exploration. A scientific law. In middle school, we observe nature's beauty. In grade 9, we dive deeper, investigating the patterns and evidence behind every falling leaf and moving ball. The natural world is extremely complex, so scientists use models, test explanations, and refine their ideas. What is scientific model? A scientific model is simplified representation of a real system focusing on important features. In physics, a moving car can be modeled as a single point, while Earth is treated as a smooth sphere. Building a model means making assumptions and deliberately ignoring certain details. These omissions are not mistakes. They are purposeful choices to keep a problem simple enough to solve. For example, imagine a cricket player hitting the ball for a 6. To predict whether the ball crosses the boundary, scientists focus only on important factors: the ball's mass, speed, and direction. But the brand of the bat, the color of the ball, or the amount of grass on the field may be ignored in a simple model. This method has led to massive discoveries. The famous physicist Meghnad Saha simplified the complex structure of stars. Did he model every single atom? No, he simplified the star into a model of hot gas, focusing only on temperature, pressure, and ion formation. This brilliant simplification allowed him to explain how a star's color is connected to its temperature. Let's look at a simple everyday example from Activity 1.1 in your textbook. Imagine you are riding your bicycle from school to your home, and you want to model exactly how long the trip will take. First, what details do we absolutely need to keep? To calculate your time, you must know the distance to your house and your average speed. But here is the most important part of building a model: deciding what to leave out. Does the color of your bicycle affect your travel time? No. What about the brand of your tires or the sound of your bell? Not at all. So we deliberately ignore them. In science, leaving out these extra details isn't a mistake. It is a purposeful choice. By stripping away the irrelevant information, we keep the problem simple enough to find the exact answer we are looking for. And that is the power of a scientific model. In science, every word and symbol matters. We use a shared precise language and standard units to communicate clearly across the world. In science, common words like force, work, cell, and reaction have very specific, precise scientific meanings. This shared language of specific terms, symbols, and units allows scientists around the world to communicate clearly without any confusion and improves accuracy. Science also uses symbols. Mass is represented by m, velocity by v, force by F, and electric current by I. Have you ever wondered why we use the letter C to represent the speed of light? In science, symbols aren't just random abbreviations chosen for convenience. They are actually based on history and international agreements. The symbol C actually comes from the Latin word celevitas, which translates directly to speed. Today, this symbol C represents one of the universe's most important physical constants. If you want a great tip for your exams, be sure to remember this. The speed of light is defined to be exactly 299,792,500 458 meters per second. However, to make math easier, it is commonly approximated as 3 times 10 to the power 8 meters per second. Using standard international units or SI units is absolutely critical. Why? Because unit mix-ups can cause disasters. Take, for example, a famous airplane incident where the ground crew calculated the required fuel using pounds per litre instead of kilograms per litre. Because of this mix-up, the aircraft was 15,000 litres short of fuel and had to make a dangerous emergency landing. Standard units SI are measurements based on agreed international standards rather than local objects or opinions. They form a shared language of specific terms and symbols that ensures a measurement means the exact same amount everywhere in the world. For example, the kilogram is a standard SI unit. Relying on these internationally agreed upon units is crucial for clear communication, preventing errors, and ensure fairness in daily life. In science, precision isn't just about grades, it's about safety and truth. Ready for more? In our next lesson, we'll master math and prediction. Subscribe and keep exploring. Happy exploring!